Hello, Mr. This is Sami Mutlaq. This is my physics project for lesson 22.1. So first we start with the properties of a nucleus. A nucleus can be specified by an atomic number or a mass number. There are three main qualities that describe the charge and mass of an atom. They are called the mass number, which is also referred to as A. Its SI unit is A, which represents the total number of protons and neutrons in the nucleus. The atomic number Z, which represents the number of protons, and the neutron number N, which represents the number of neutrons. Having two of these values allows you to get the third value. For example, an atom with an atom of aluminum has a mass number of A of 27 and an atomic number of Z of 24. Therefore, we can predict the neutron number has to be 14, which gets the equation 27 minus 13 equals 14. Next, we are going to talk about the mass number and the atomic number. The mass number and the atomic number are usually written by the chemical symbol of the atom before the chemical symbol. As we can see here, the mass number, the atomic number is 13, while the mass number is 26.9 or 27. An element can be defined by its atomic number because the number of protons determines the element, which in this case 13. Although the atomic number does not change, the mass number can. This is because the number of neutrons in particular element can vary. The atoms with the atomic number with the same atomic number but different neutrons are called isotopes. The neutron number of an isotope can be found with the equation A equals Z plus N. Now, with the properties of a nucleus. A nucleus is very dense. Experiments have shown that most nuclei are approximately spherical, and the volume of a nucleus is proportional to the total number of protons and neutrons, and thus to the mass of the nucleus. This suggests that all nuclei have nearly the same density. Properties of a nucleus. Unified mass unit and rest energy define the mass of a nucleus. Because the mass of a nucleus is extremely small, the unified mass unit, U, is often used for atomic masses. The unit is referred to as atomic mass unit. Alternatively, the mass of the nucleus is often expressed in terms of rest energy. A particle's rest energy is associated with the mass with the equation E equal mc squared. Now, it should be ER, but I couldn't find a proper picture, so E equals mc squared, where E is the mass, E is the energy, m is the mass, and c is the speed of light. So the resting energy should be E, which equals the mass times the speed of light squared. Nuclear stability. The nuclear force, or the strong force, is what keeps the protons from flying apart. The strong force is very different from other forces, making it almost completely independent of electric charge. The force of attraction between two protons and two neutrons or one proton or one neutron is nearly the same. Neutrons help stabilize a nucleus. For a nucleus to stay stable to repulsion between positively charged proton for a nucleus to stay stable from repulsion between positively charged protons, it must be balanced by the nuclear force's attraction between all the particles in the nucleus. Meaning, for the protons to stay together, there must be some form of attraction that keeps the protons together. The repulsive force exists between all protons in the nucleus because the electrostatic force is long range, meaning the protons, even if they might be far, they can still repel each other. But a proton or neutron is only its nearest neighbors, because the nuclear force is short range, so it only affects the nearest neighbors. So the number of protons increases the number of neutrons. So as the number of protons increases, the number of neutrons has to also increase in order to maintain stability.